Last time, in the last session, you covered intersecting lines and parallel lines and perpendicular lines. Am I right?
Yes.
Okay, sure. Now we are going to use something very unique with that particular information. Now, let's say we have two lines together. This line is moving from here to here, and another line is moving from here to line. When you have straight lines, it is only possible for them to meet at only one point. So we are interested in the point at which they meet because we say every point has coordinate x comma y. So
And
when two lines are moving, we are interested in where they meet. Two lines can only meet, two straight lines can meet only at one point. So we are looking for that particular point that they meet. So this particular line can have like equation 1. So let me call it y1. Yeah, let me call it e1, and this one too can have equation 2. So this equation, this line has its own equation, this also one also has its own equation. From the equations, how do we now get the point where they both meet? That's going to be the first thing that we'll be covering in this session. um Kennedy, how are you?
service amplified.
Okay, sure. um let's now see. So given two equations, I have some sample equations here that I'll put on the board. uh, Let me see. The first one, I have y1 equals to 2x plus 5. That's the first line. And the second equation, the second line has the equation y2 is equal to negative x plus 1. So we want to find this line and this line. So let me call this one L1, this is L2. So line 1 and line 2, we're interested in the single point where they both meet. Because if you have two straight lines have can only meet at a maximum of one point. So that particular point is going to be a unique point for both lines. So how do we find that? At the point where they meet, it means that at this particular point on this line, and then the point on this same line, the two lines have a unique point where the y value and the x value is the same on both lines. Let me come again. When they meet, where they meet, the place where they meet, like this place in this case, there's a unique point. There's a unique point with coordinates such that that coordinate satisfy the line 1 and line 2. So we need to make sure at that point, meaning that the y of this line, the y from y1 will be the same as the y for y2 at this particular point. So it means, and the condition is that at that point y1 will be equal to y2. So y1 from the first point will be equal to the y2. The same thing will apply to s1 is equal to s2. So at that point of intersection, this is the condition that is satisfied. At the point of intersection, y1 of the first line is equal to the y2 of the second line. Y of the second line, the s of the first line is equal to the s of the second line. That's the condition at the point of intersection. Now, we are all used to this format where we have y is equal to mx plus c. So if you have two equations like that where at the point of intersection they all have the same y, what you do is that you need to transform your equation, whatever equation, into this form: y is equal to mx plus c. This is the first thing that you need to do. Make sure that you transform your equation of a line. All of them will not be in straight form like this. You have to now convert it into this format first. After doing that format, now you compare the two equations. Let's look at this one. So this one is already in that form: y is equal to m is 2 mx plus c, and the c is a constant here. The same one is mx plus c already, so only y is at this side. So if you have it in that format, then in this condition you can say y1 is equal to y2. So y1 is equal to y2, meaning that you have to equate whatever you have here to whatever is on the other side for the other line. So in another way, y1, we know that y1 is 2x plus 5. will be equal to the y2. The y2 has negative x plus 1. So you write the expression. So this is what we have. Y1 is equal to y2. And then we know y1 is the same as 2x plus 5. That is what I wrote here. Will be equal to, this equal to sign comes here, will be equal to y2 is the x expression of the y2 is what I wrote here. So you can see that I'm writing only the x expression, the expression that contains the x here. Y doesn't appear here. So this is the condition. Then you now write the x expressions here. Then from there, you now derive the equation. Take note of something, that I'm not labeling the x as s1 or y1, because at that level s1 will be the same as s1 will be the same as s2, so it's all x. So now at this point, you now find the value of x first. So let me find the value of x from this equation. I'll group like terms. 2x will be on this side. I'll take this negative 1 to this side, become positive x, which will be equal to, then positive 1 is already here. I'll take this negative 5 to the other side. Then if you do this, you are going to have 3x equals to negative 4. Now, my value for x will be negative 4 over 3. So I have the value for x already. Now, when you get the value for x, how do we now find the value for y? Because a point P should have x coordinates, comma y coordinates. After you find x, which is the common point of intersection, you need to now put that particular point into one of the equations. You can put it in any of them. You can put it here, or you can put it in the first one. Let me put it in both, just for learning sake. But I'm going to put it, you just have to do it for one. You put this x value in one of them to find the equation. So I have, let me take y1 is equal to, y is equal to 2x plus 5. So 2x plus 5. Let me see what I will get for y. I have y equals to 2 into brackets negative 4 over 3 x plus 5. When you do that, I think we are going to have y equals to negative 8 over 3. Oh, what am I doing? Oh no, the x shouldn't come again, because we have replaced the value of x by this. So this x is being the one here. So that's what I used to replace here. So we have negative 8 over 3 plus 5. This should give me negative 8 plus 15 all over 3. Then y should be equal to I think 7 over 3. So y is equal to 7 over 3. So the point of intersection, so let me, this is what I did for y1. Let me try it for the second line as well, to see if I will get the same thing. This is what I have. Y is equal to negative x plus 1. So y equals to negative x plus 1. I'm trying for the other line. So I'll put in the value for x. The value for x that we got was negative 1 over 4. Negative 4 over 3. Right? This is the negative 4 over 3 x minus. This minus is the one at the front, but x itself is negative 4 over 3 plus 1. This will be equal to positive 4 over 3 plus 1, which is the same as 4 plus 3 all over 3. And that will give us y equals to 7 over 3. So at the end of the day, I got the same thing, because this is the point of intersection. So basically, the point of intersection P is negative 4 over 3, comma 7 over 3. This is what we were looking for. That becomes the point of intersection for this line, where we have y1, y2, y3. Let me use another pair of equations to illustrate. So far, do we have any question or something I need to go over?
No.
Okay. Kennedy, are you fine?
Yes, sir.
Okay. Sure. Let me take another equation. Maybe you can try to solve it alongside to see if we'll get the same thing, if you really understand. But if you don't, this equation is for me. By all means, I'll give you questions to solve. I have a lot of them here. So I have 3x minus 2y equals to 6. And the second one, and The second equation is x plus y equals to 4. The first rule or the first thing that you need to do is to make sure that you have it in the form y is equal to mx plus c. So I'm going to do this one, convert it to the format that is mx plus c. I'm going to have negative 2y. So I'm basically make y the subject to be equal to negative 3x, because positive 3x is going to the other side, plus 6. Then I have negative, so I will be having y equals to 3 over 2x plus 3. Oh, no, it's not going to be plus 3 because I'm going to divide through by negative 2. So that will be negative 3. Yes. So I have in the form y. Yes.
I said it was a mistake, sorry.
Okay, sure. So I got it in this form here, y is equal to mx plus c. Let me do the same for this one. I'll have y equals to, I'll send the s to the other side, become negative x plus 4. So this is also in the form y is equal to mx plus c. When you are done with that, because you are looking for the point of intersection, what you do is that you now equate the s expressions together. So it become 3 over 2x minus 3. That will be equal to negative x plus 4. So I'm taking the x expression from here and I'm equating it to the x expression from here, basically. And from there, you now find the value for x. So I'll have 3 over 2. I'm grouping items. The negative x will become positive x on this side. And negative 3 will go to the other side, become positive 3 plus 4. If I do that, I'll have this and this. That will be 5 over 2x equals to 7. So it means I'll have x equals to 14 over 5. So this is the value for s I have. At the end of the day, you go back, you take one of the equation, you put in that value of s. So among the two, this is simpler for me. This is simpler for me. So I'm going to take this one and use it to find the value for y. So y is equal to negative x plus 4 from that equation. So I have y equals to, I will now put in this new value of s that I got here, negative 14 over 5 plus 4. That will be equal to negative 14 plus 20 all over 5. Then y equals to 6 over 5. So this is the value for the x. So therefore, the point of intersection P is the x value first, 14 over 5, comma, the y value 6 over 5. This is the point of intersection that we are looking for. Are we good? Yeah, are we good?
Yes. Yes, sir.
Okay, sure. But then there is a catch, right? Before you do all this process, you have to be careful before you even start, or especially when you stop at, after making this in the subject, there's a step that you need to do before you even equate the two equations. If not, you'll be stuck ahead. After making this thing, so I make this one y is equal to ms plus c, you also make this one ms plus c. You need to be very careful before you proceed, or to save your own time. You need to check something very quickly. It's about the gradient. It's about the gradient. You check the gradient first. See, when you have points that only points that can only meet are intersecting points, either just intersecting or perpendicular. Only those parallel lines never meet. If the lines are parallel, they never meet. So you need to make sure that the gradients are not the same. If the gradients are the same, then there is no point of intersection. That's what you need to check before you even proceed to equate, to do this particular thing that we were doing here. After making y is equal to ms plus c, and for the other one and for this one, before you proceed, quickly check the equation of the gradients first. If the gradients are the same, then there's not going to be any point of intersection. So you leave it like that and your input that there's no point of intersection. But if they are different, then you can proceed and find the equation of line, because only intersecting lines can have a point of intersection, but parallel lines cannot have. In that light, let me give an example. Have y is equal to negative 3x plus 2 and 3x plus y equals to 7. So the first step is to make sure that you have something in the form y is equal to ms plus c. This guy is already in that form already, so I will not even sweat about on it. I will now go to this guy, make y the subject. I'll have y is equal to negative 3s plus 7. After you got here, before you even proceed to equate the s expressions, you need to quickly check the gradient. The gradient here is negative 3 and the gradient here is negative 3. Therefore, there is no point of intersection. That's your answer. So no point of intersection. That's your final answer for that. Are we good?
Yes,
Yes,
sir.
sir.
Okay. So if that is good, then let me give you guys some examples to try. So I'll give this one to Yao. Yao, we have this particular pair of lines. Sorry. So we have y equals to half x minus 3, and the other line is going to be y equals to negative 2x plus 5. Yeah. So Kennedy, you have this. This for Ken. Ken, you have 2x minus y equals 7 and 4x minus 2y equals to 10. So can you all see your questions though?
Yes, sir.
Okay, so anyone that is ready, just give me your answer when you find. If you face
Sir,
any difficulty, yes.
my own, they don't have any point of intersection.
Hey,
The
why?
gradients are the same.
Gradients are the same. So what's the gradient for this
Yes,
one?
2.
So let's make this in the subject. So we have y is equal to 2x minus 7. For this one, we have what?
The second one, we have
Y is equal
y
to
is equal to
2s,
2x minus 5.
yeah, minus 5. So the gradients are the same, so there is no point of intersection. That's correct. So yeah, that's true. Um, Let me give you another one then. That one was easy. Let me see. We have 5x plus y equals to 9 and negative x plus 3y equals to 7. Do you have your question?
Yes.
Okay. Yeah, when you are ready, let me know.
Okay, sir.
Sir,
Yes, Kennedy. Are you ready?
yes, sir.
Yes.
Okay. So, what do you have?
I
Choice
got my x value to be 5 over 4.
5
13.
over 4.
Yes, and the y value to be 11 over 4.
So please root
11
to
over 4.
16.
Okay, let me confirm that.
Thirty.
You said, so you will have, for this one, you have y equals to negative 5x plus 9. For this one, you will have y equals to positive 1 over 3x plus 7 over 3. So if you equate these two sides, negative 5x plus 9 will be equal to 1 over 3x plus 7 over 3. No, then we are trying to find negative 5x minus 1 over 3x be equal to 7 over 3 minus 9. So this one will give me negative 15 minus 1 all over 3. X. Am I doing something wrong? But let me continue. So this one will be 7 minus 39. That will be 36, right? Oh no, that will be, oh, what am I saying? 39, that will be 27. 27 over 3. So I'll have something around negative 16 over 3x will be equal to negative 20 over 3. At the end of the day, x will be equal to 20 over 16. Dividing through by 4, we have 5 over 4. So you had 5 over 4. Okay, Kennedy had 5 over 4. So that one was correct. Let me put in into one of the equation. So if I put it here, oh yeah, that's simple for me. So 5x plus y. So 5x plus y equals to 9. If I put in the value for x, I'll have 5 multiplying 5 over 4 plus y equals to 9. So that's supposed to give us something like y equals to 9 minus 20 over 4. So 9 minus 25 over 4. And then for 9, that will be 36 minus 25 all over 4. And yeah, that's 11 over 4. Yeah, Kennedy, that's correct. Well done.
Sir,
Yes, yeah.
I I also had x
Let me
is
see.
equal to 16.
So P is what?
X is 16 over 3 and 13 over 6.
13 over 6. Okay,
Mm.
let's confirm your answer as well. Give me your two equations. Y equals to what?
Y is equal to half x minus 3
And
and y is equal to negative 2x plus 5.
plus 5. So the ingredients are already there. So if you compare, yeah, they are not the same. So you need
Yeah,
to proceed.
they are the same.
Yeah, minus 3 will be equal to negative 2x plus 5. So we have half x plus 2x equals to 5 plus 3. Then that will give us something like 5 over 2x equals to 8. Then x is equal to 16 over 5. Is that what you had? Did I do something wrong?
Yeah, I did something wrong.
Oh, you did something wrong. Okay, okay.
Yeah,
Take your time. Okay. So you have half
okay, sir.
minus 3. You put in the value of x. You have y is equal to half times 16 over 5 minus 3. That should lead us to y equals to 8 over 5 minus 3. Yeah, I think we'll still have the y equals to negative 7 over 5. Yeah. So now, okay, let me throw you guys another one so that we, those of us that had made a mistake, we um, get some scores. So yeah, I'm coming to give you another one So you have
Okay, sir.
0.5x minus y equals to 1 and x minus y equals to 4. Then, Kennedy, are you there?
Yes, sir.
So you have 3y minus x equals to 12 and 2x plus y equals to negative 1. Let's do this last one so we can move to another concept.
Sir,
Yeah, who is that?
Kelly,
Okay, then what do you have?
I have my x value to be
Like, give me the points, right?
negative 50. Yeah, negative 15 over 7. And my y value to be 23 over 7.
Okay. Yeah, are you ready? Yeah, are you ready?
No. No, sir.
Okay. So yeah, this one, if that's correct, you have to go through that entire process again before you can confirm. So I'll leave that to people watching to confirm that your answer was correct, Kennedy.
Okay.
Okay, sir.
Negative 3.
So we'll be moving to another concept.
3 times 2.
Yeah, do you need
Negative
help?
2. No.
Okay.
Yeah, I'm on the second one. So I found my x.
Okay,
I
sure.
found my
That's
x.
good.
One is to y is equal to yeah. So um I have my point to be 6,2.
Wow, interesting. Yeah, I'll leave the same thing for people to also confirm. Now, so that's about when you have two lines and they meet at a point, you are able to find that point of intersection. There's another thing that we can also find between two intersecting lines. What we are going to find is also going to be about two intersecting lines. So parallel lines, yeah, kind of, but not really. So what we are going to be interested in is now the angle, especially the acute angle. So if two lines are meeting, there's an angle made here. This angle is equal to this angle, and then this angle here is equal to the angle here. So opposite angles are equal, basically. But we are interested in the smallest angle first. When you're able to get the smallest angle, you can subtract from 180 degrees to get for the larger angle. So the smallest angle is called, we are going to, is the acute angle. So find the acute angle between two intersecting lines. It means that the smallest angle here, this one is equal to this. So one, you just focus on one and find it. And then the other one, if you want to find the largest one, you have to find the obtuse. Obtuse is just basically 180 minus the acute angle. So the main focus is about how to find the acute angle first. And if they are just asking for the acute angle, then you are good. If they say find the angle between two intersecting lines, they are just asking the acute angle. But if they specify that find the largest angle between two intersecting lines, largest is the obtuse. Are we good?
Yes, sir.
Okay. So
Yes, sir.
the way to find that angle is basically using tan theta equals to the absolute value of m1 minus m2 all over 1 plus m1 times m2. So there are two lines that have their own gradient. So here we are just going to use their gradient to work to find the acute angle. So basically the angle is actually this theta. So if you are able to find tan theta, you'll be able to do the tan inverse to find theta value itself. So we've had some equations at the top. That's why I was not cleaning them. We have a lot of equations at the top that we are going to try. Okay, so in this case, we are not interested in the point of intersection. We are interested in the um, angle of intersection, or yeah, basically. So let me clean this one and start from here. So there is just one formula that goes across all that, and that formula is let me clean this two, this go. Yeah, so I have two lines and I'm asked to find the angle between them. So the general angle is tan theta. The general formula is tan theta. Theta is the angle equals to absolute value of m1 minus m2 all over 1 plus m1 m2. Absolute value just means that you ignore the negative. Always, whatever you find, you make it positive. So if your final answer from this fraction is 1, the answer will be 1. If the final answer is negative 1, ignore the negative and just write 1. So we are interested in the positive answer. That's why we have the absolute here. Absolute just means that we are basically interested in the positive values. So if it is positive, make it positive. If it is negative, make it positive. All the time. Are we good?
Yes, sir.
So for these equations, our m1, any of them can come. So our my m1 is equal to 2 and my m2 is equal to -1. It doesn't really matter which order you do it, but then because of the absolute value, it will still cater for whatever you do. So I have tan theta will be equal to absolute value of, now I have a fraction inside, 1 plus m1. The denominator is m1 times m2. So my m1 is 2 times -1, and the numerator is 2 minus -1. 2 minus -1. So I have tan theta will be equal to absolute value. The top will be 3 all over 1 minus 2. That will be -1 at the bottom. That will give me absolute value of -3. What's the absolute value of -3?
3.
Yeah. So it's tan theta equals to 3. Now we are looking for theta is of the acute angle. So theta is equal to tan inverse of 3. So what is theta? Anyone has the calculator there?
Sir, is 71.565 degrees.
71.565 degrees. So this is the angle or the acute angle between them. Acute angle are usually less than 90 degrees. So yes, if the lines are parallel, right, there's no angle between them. If the lines are parallel, they never meet, so there's no angle between them. The angle there is 0. Tan 0 is 0, right?
Yes, sir.
Yes. So the angle between them is 0 degrees, basically. If they are parallel. If they are perpendicular, the angle between them is what?
90.
Yeah, if two things are perpendicular, the angle between them is 90 degrees. So that's what you need to also look at. If the gradient, the product of the gradient, m1, m2 is equal to -1, then you are going to have a perpendicular line. So now let's go and test on the next equation. Let's find the angle of the next one. And then you guys will find the angle of the one that you solve yourself. So we are going over the same equations of lines. And yeah, I think I've solved another one. Right, let me clean this side. I'll solve another one before I give you guys questions. So let's find the angle for that one. Yeah, I forgot where I had it. These are yeah, I think it is this ones. So yeah, this is where I make y is equal to, I'm able to find, yeah. Okay, so let me find the angle for this one as well. Then you guys will find for your own. So again, I'll use the general formula. Tan theta equals to the absolute value of m1 minus m2 all over 1 plus m1 m2. So that will give us tan theta to be equal to m1 is what I need to find my m1, so I'm saying my m1 is equal to 3 over 2, and my m2 is equal to, from here is negative 1. So I'll basically have 3 over 2 minus 1 all over 1 plus 3 over 2 multiply negative 1. So what am I going to have at the top here? You guys can help me find the angle. So the numerator, I have 3 over 2, that will be 5 over 2 all over 1 minus, so that will be negative 1 over 2, I guess. Let me see, 2 minus 1, yes. So this will give me something like negative 5.
5.
So it's going to be 5. Yeah, so tan inverse of, so theta will be equal to tan inverse of 5. Tan inverse of 5 point
78.69 degrees.
69 degrees. Yeah. So this is the value for the acute angle between the two lines. Okay.
My calculator here.
Are we good? Yeah, are you good?
Yes, sir.
Yes, sir.
Yeah, but I don't have my calculator here.
Okay. So yeah, you need to solve for the angle between these two, and then Kennedy, you also find for yours. Don't you have a calculator on your phone, Edu?
Yes, sir.
Yeah, you can use it to find the
Yeah,
angle.
but that one, but that one I can't punch a tan theta.
You don't have the scientific one.
Yeah.
Yeah, you can give your values, right? The value that you finally get, so that we see. Kennedy will put it inside the calculator for you.
Okay, sir.
Let me go top so that you guys see your equations again. Yeah, these are your equations. Let's find the angles, the acute angle.
Sir,
Yes, are you done?
yeah, I got theta to be 82.87 degrees.
Okay, we'll go through the process to do that. What do you have? Yeah.
So let's have it. Let's have it together. My
What value are you putting in your calculator? That's what I
I'm not
want.
sure.
Okay, sure.
Um,
Let me confirm Kennedy's own then. So Kennedy, your M1 should be negative 5, right? And your
Yes,
M2
sir.
should be 1 over 3. Then tan theta will be equal to, I can go in any order, so let me do 1 over 3. I like putting the negative ones at the back, but they won't change anything. 1 plus negative 5 times 1 over 3. That will be equal to so the numerator here is 1 over 3 plus 5 all over 3 minus 2, 3 minus 5. That will be negative 2 over 3. So at the end of the day, I have something like the numerator, I have 16 over 3 times 3 over negative 2. Then this one will cancel this. Then negative 2, absolute value of negative 8, which is equal to 8. So we found tan inverse of 8. Kennedy.
Yeah, yes, sir. Now I got 82.87.
Okay, sure. Now let's find, yeah, I was small. Yeah, we have your negatives here. So let me have tan theta will be equal to, so my m1, your m1 is equal to half, and your
Half,
m2
yeah.
is equal to -2. So
Negative
m1 is
2.
half minus into bracket -2 all over 1 plus half times -2. So this will be equal to, the numerator will give me half plus 2 all over um
1, 1 minus 1.
1 minus 1, right?
It's 1, yeah.
So it will give you 0. The thing is, if you find the product of, so if you do m1 m2, you are going to have -1, meaning that they are perpendicular, right?
Yeah.
If they are perpendicular, what's the angle? If they are
Said
perpendicular,
if they are perpendicular,
what's the angle? What's the angle
it has no
between?
point.
You are not looking for points, you are looking for angle.
Say it's right angle. It's 90 degrees.
Yeah,
It's 90
it's
degrees.
90 degrees. So you have to check that. I think I didn't specify it now on that. So when you have the gradient, check if they are the same. If they are the same, then the angle is just 0 degrees. If they are perpendicular, meaning find the product of the two, it is -1, then the angle is just 90 degrees. So you don't even do any calculation there. Very good.
Yes, sir.
Yeah, Kennedy, are
Yes,
you
sir.
fine?
Yes, sir.
Yeah. So yeah, you can work on the try on the other one because it's time. You can try the other ones on your own to solidify your distance. So we had this point, these lines, right? We have another one here. You guys can try this on your own to just solidify the concept. Yeah. But that this is it about finding the angle. So you can find the obtuse. If it is the obtuse they are looking for, then if you had 90 degrees, for example, or like you have the 82.87, for example, if you're looking for the obtuse, this is the acute. By default, is acute. For the obtuse, you just do 180 degrees minus the answer that you get, 87. That will give you the obtuse angle. Are we okay?
Yes, sir.
Yes, sir.
Yeah, that's all.